Okay, good morning, girls.
Good morning, sir.
Today we are going to start matrices and determinant, right? So before we start matrices, we must understand what are matrices. You have already finished matrices, must have finished in your school, right? So you can define what's matrices. What are matrices?
To arrangement of numbers in rows and columns.
What is it?
Tabular arrangement of a particular of some numbers.
Basically, matrices are a structure. It's structure, है ना? And basically in a fashion of rectangular array. So you see numbers written in rectangular array. Array means a structure, okay? So if I say something like this, so you see there are some rows and there are some
Columns.
columns. How many rows you see?
M.
How many rows? One, two.
M rows.
So you see m rows, right?
M
And how many columns
columns.
you see?
N columns.
M columns. So this is basically a representation of matrix, a rectangular array. So you have a rectangular entries of numbers, right? This first entry is called first row. The second, this line is
Second.
called second row, this way, and this is called columns. First column, second column, third column. So as you can see, the rows are one, two. Every element has subscripts. You see a pair of numbers. So they are not one number. It's not 11. It's 1 1. It's 1 2. It's 1 3, and then you have 1n. So first guy and then the nth guy. So what does it represent? Let's say we'll go into the detail right now, but ये सारी चीज़ें दिख रही है, and this is a rectangular structure. This is called
Order.
order of
Matrix.
order of matrix A. So order is always written into the form of number of rows into number of
Columns.
column. The number of rows has to be written first and then the number of column. And the whole structure is usually denoted by
A.
the capital A. The other representation can be this way. A is equal to A I J M cross N. Right? Understood? So other way of writing the whole structure is Aij M cross N. I belongs to 1 to
N.
M, where M and N are natural numbers, right? M and N are.
Natural numbers.
If I don't write M, N is a natural number, what this signify? It signifies all the numbers between 1 and M. So we must mention that M N is the belongs to
Natural numbers.
natural number. This is the story of matrices. This is how we define, and we usually define in terms of Aij as well. Okay, what's there in the door? Why you people are looking regularly there? You can focus here, no? So understood what is matrices? Okay, so matrix is basically a rectangular array. You have rows and you have columns. Okay. Now we'll start defining various terms related to this. Okay. So the first thing which it is going to come up is called upper triangular matrix. What is upper triangular matrix? Huh?
All the rows inside
What the lower elements?
The diagonal starting from the left hand corner.
Define in terms of Aij.
All the elements below I equal to j are 0.
If you see, these guys belong to the diagonal matrices, right? So what you see, whatever the elements you find below has to be 0. What's common to all the suffixes which are below this? Okay, what about this line? This line is equal to m is equal to n, right? So you see on the lower side, all the first number is greater than the second number, right? So I must say that if Aij is equal to 0 for I greater than j, then the matrix becomes, which matrix? Upper triangular matrix. This is the symbolic representation. Everybody understand this? Structure representation तो बहुत आसान है देखने में, but this is the symbolic representation of upper triangular matrices. See, all the elements which are below the diagonal. Diagonal is something like principal diagonal. We call that diagonal as principal diagonal, where both the subscripts are equal. I is equal to j. So you understand. Why did you leave the class? So this is a rectangular array, m cross n. You have m rows and n columns. So you have matrix A and you have m cross n. This m cross n is called order of matrix. Now this is the structure representation. Now this is the representation through symbols. So you have A, Aij. Aij is nothing but the elements of that structure. Aij constitute that structure. Now this represents the order, and Aij means I belongs to 1 to m, which means it can be of one of the rows, and j means it signifying which column it is. We have already understood coordinate system in which we say abscissa and ordinate, which specifically defines where exactly the point is. Exactly Aij, the number I and number j exactly defines which row and which column. I represent the columneth, roweth, and jth represent the columns. Understood? So if I say A23, what does it mean? This guy belongs to second row. So this is the second row and this is the third column. So who is the guy? A23, right? Understood? This is how we represent. Now the first term after general representation, rectangle. So matrices में keywords क्या हैं? Rectangular array. Rectangular array. Array means structure. And then you have number of rows and then you have number of columns. Order is m cross n. Right? यहाँ तक we are clear? The second important term is upper triangular matrix. Upper triangular matrix in which all the elements below the diagonal are 0, which we are going to say mathematically that Aij is equal to 0. This symbol represent for all I greater than j. Why do we call I greater than j? Because these elements, let's say if you see a rectangular array of 4 by 3. So this is 1 1, 1 2, 1 3, 1 4, 2 1, 3 1. 4 rows है ना, sorry. A4 1. So this is your rectangular array. Now this guy is principal diagonal. So these guys has to be 0. Clear or not clear? समझ में आया? Which guys? These guys. What's common in these guys? The first guy is इसके जो आप suffix देखेंगे I और J में, तो I is greater than J. So at the same time you can tell me what is the lower triangular matrix? तो सारे elements above the diagonal matrix, principal diagonal is called 0. They are 0, right? So we understood 3 terms. What are those 3 terms? We understand matrix, We understood matrix A. In this, we understood terms like order, element, I, J. We understand these guys, right? And then we understood upper triangular matrix. We understand that Aij is equal to 0 for all
I greater than J.
J. And then we understood lower
Triangular
matrix,
matrix.
and
Aij is equal to 0 for all
Aij is equal to 0 for all
J greater than
J greater than I. And then we also understood what are principal diagonal. What is principal diagonal? प्रिंसिपल डायगोनल्स के एलिमेंट्स कौन होंगे? ए आई जे फॉर ऑल आई इक्वल टू j, right? See, we are heading somewhere, right? We started with matrix, we understood what is upper triangular, we understood what is lower triangular, and now we understand what is principal diagonal. So now it's time to define diagonal matrix. What is diagonal matrix? You can say it is both upper triangular as well as,
lower triangular.
or you can say the principal diagonal has to be non-zero guy. So I can say diagonal matrix is Aij is equal to 0 for all I not equal to, है ना? And Aij is equal to, it can be anything, right? It can be anything. So you call it principal. क्या हो गया? Not able to understand. Understand. Okay. So matrix समझ में आया, upper triangle समझ में आया, lower triangle समझ में आया, and then you understood principal diagonal, and then you understood diagonal matrices. Diagonal matrices मतलब वो upper triangular भी है और lower triangular भी, means all the elements above the diagonal and below the diagonal are zero, and then you have non-zero guys inside the diagonal. Okay. और diagonal के element हम कैसे represent करते हैं? When I is equal to j. Okay, good. So diagonal matrix में we are coming to the new term, scalar matrix. Can anybody define what is scalar matrix?
All the diagonal elements are 1.
One or constant? Constant. So diagonal matrix, so sometimes we represent this way. What does this represent?
Diagonal elements are 1.
Okay, before diagonal matrix I missed one thing. What is square matrix?
In which the number of rows and columns are
Number of rows and number of columns are equal. So basically when I write diagonal 1 3 7, diagonal matrix are always represented as of a square matrix, right? So we understood this is 3 by 3. 3 by 3 matrix. So basically इसको structure करोगे तो क्या बनेगा?
1 3 7 0 0 0.
So this is your diagonal matrix 3 by 3. Understood? So diagonal matrices are already square matrices. Clear? इतना तो issue नहीं है. Okay. Square matrix is simply nothing but m is equal to n. The rectangle becomes the square, means number of rows is equal to number of columns. So your diagonal matrix, so sometimes you write this way and usually you write this way. Okay. Now when all the elements of diagonal matrix, when I say diagonal matrix, it's very clear that upper triangular भी है और lower triangular भी है. So the moment I say all the entries of diagonal elements is constant, C, C, C. So this matrix is nothing but this. And what do we call this matrix as?
Scalar matrix.
Scalar matrix. So we have understood what is scalar matrix, right? We are just getting familiar with the terms, that's it. So we understood scalar matrix. Now when the entry C becomes 1, then it becomes unit matrix or identity matrix. And when all the elements become 0, what is it?
Null matrix.
Null matrix. So do we understand how we started and where we are heading right now? हाँ, यहाँ तक कोई doubt है? So we started with matrices, upper triangular, lower triangular, square, diagonal, scalar,
Identity.
identity,
Null.
null. So we got 8 terms, right? And all our stories are clear how we are coming up. Now there is one term called trace of a matrix. What does trace of a matrix? Trace of a basically trace of matrix हमेशा square matrix का ही निकाला जाता है. So what is trace of a square matrix? Anyone has any idea? No, not transpose. Trace of matrix means simple. It's a very simple thing. If you see the diagonal elements, you just have to add them together. That is called trace of. So diagonal matrix के addition को कहते हैं हम trace of matrices, right? Okay, as we understand, matrices are a structure, right? How the equality implies. You know why we are studying matrices and determinant? Why? We haven't finished vector and 3D, right? And still we are studying, which is not very scientific. We must first understand what are vectors and 3D, then we should start matrices and determinant. But in NCERT, they have given this pattern and schools are following, so we cannot do anything. But it's just a mechanism to handle the calculations of vectors and 3D. So we create rules, mechanism to structure things. Even if you go, and matrices has a very strong applications in computer world. Even in Googling, what you do, the Google thing, it's a matrix structure. So we'll understand, and then I will be giving you a little idea about 3D and vector also when we'll be going further, right? I hope in schools you have already done vector 3. No, you haven't started. Okay, no issue. I'll take care of that. So you understand this? यहाँ तक clear है सब कुछ? So these terms are pretty clear to you guys. अभी you must be doing the matrices just as a meaningless things कि ऐसे करना है, ऐसे करना है, ऐसे करना है, right? But it will start making sense if you study vectors and 3D, because it's a tool to handle vectors and 3D. Matrices and determinants are nothing but a tool to handle. When we were doing coordinate geometry, I think we used certain places determinants, right? And then you have already used this determinant in solving linear equation in two variable in class 9th. You used to create the formula a1 b2 minus a2 b1. Those all are structure which is emerging from vectors and 3D. Okay. Yes, identity matrix is a scalar matrix, of course. Now, when do we say two structures are equal? Just order.
And all the elements corresponding.
All the corresponding elements has to be same. When both the corresponding elements has to be same, it means they are equal. So structure में आप ऐसे नहीं कह सकते हो कि कुछ भी equal है. In matrices देखो ऐसे क्या होता है जब आप बचपन में पढ़ते हो 4 into 3 is equal to 3 into 4, but that is not true, है ना? The matrix tells us that is not true. Why? Because if you say 4 copies of 3 bananas and 3 copies of 4 bananas, are they same thing? Yes, the quantity wise they are equal, but they are not equivalent. Okay. Same way we have to be very careful because we are not dealing with just numbers, but we are dealing here with structure. Okay. So when you see equality of matrices, when we say two matrices are equal, first their order has to be same, and second the corresponding elements has to be same. Then only we are going to say the two matrices are equal. Understood? How are we going to add two matrices? First the order has to be same. First the order has to be same, and then corresponding elements will be added to each other, right? I hope no issue in this. And when do we subtract two matrices? Again the order has to be same, and then corresponding elements will be subtracted from each other. Clear or not clear? Now come to when we multiply any matrices by a scalar, what does happen?
Each element of the matrix gets multiplied by that.
Why each element is getting multiplied? Any logic? My body is a structure. If you're going to make me 2x, my nose, my ears, my eyes, everything has to become 2x. Understood? Otherwise, I won't be called 2x of me. नहीं तो मैं कुछ दानव बन जाऊंगा, right? कुछ different सा शक्ल बनेगा, not in human form, या not exactly my form. So it has to be every part of me is getting 2x. Clear? Same way, matrices is a structure and we are multiplying that structure by something with lambda times. So every element has to get lambda times. If we are shortening them, then also nose has to be shortened, eyes has to be shortened, ears has to be shortened. Okay. Similarly, negative. So everything has to be negative. Understood? So every element will be multiplied by. लेकिन determinant में ऐसा नहीं होता है. If you multiply determinant by a scalar, only either one row or one column, any one row or any one column will gets multiplied. So you should be very clear with that. And how do we multiply two matrices? What are the first conditions you need to know? If I say
Number of rows, number of columns of the first matrix should be equal to the number of rows of the second matrix.
now let's say this is A into B. This is
A into B.
this is matrix A and this is matrix B, and you have the order as m by n, and this order is, so what is the condition first to have B A B?
To B.
N is equal to P. Then only we can proceed, otherwise we cannot proceed. Now how do we proceed?
First row into the first column.
This is row 1, this is
Row 2. Row M. C1. CL.
C
Q.
Q. Now we understand N is equal to,
P.
means all the how many elements you have in R1? N elements. And how many elements you have in C1?
P.
P. And they have to be equal. Why? Because we are we consider this as a vectors, components of vectors, and this also considered as a component of vectors. And multiplication means simply taking dots, and when we are taking dots we need each component, I के साथ जाएगा, J के साथ जाएगा, K के साथ जाएगा. Similarly जब हम M N dimensions में चले जाते हैं तो वैसे ही components break करेंगे और उसी components को अपने corresponding components के साथ जाएगा, right? So the AB would be R1 dot C1. So this vector getting dot with, I hope everybody understand dot product. I goes with I, J goes with J, and K goes with K. So R1 का हर एक element, first element will go with first element, second element will go with second element, third element will go with. So first guy is R1 dot. This is a, if it is 3 by 3 and 3 by 3, this becomes IJK form. But vector ऐसा नहीं है कि 3 form में ही हो. It can be more dimensions also, right? So आपने इसको क्या कहा? R1 और इसको कहा C1. So the first guy of the product is R1 dot C1. The second guy would be
R2 dot C2.
no, R1 dot C2. The first row will always have R1. So first row of the product will always have R1 और एक बार ये सबसे लेता चला जाएगा. So it would be R1 dot C3 and so on
R1 dot CQ.
CQ.
Q.
So this is the first guy of the product, the first row, right? Similarly, I hope you have guessed it. R2 dot
C1.
R2 dot
C2.
R2 dot
C3.
and so on.
Dot CQ.
CQ, and same fashion we will go till Rn dot C1, Rn dot C2 and
Rn dot C3 till
Rn dot CQ. This is how we are going to proceed, and it is a tiring task. Okay, but in competitive examination they don't ask you the matrix multiplication, but they ask something like, they have given this matrix, they have given this matrix, they want you to find A23 of AB. So how to find A23 of AB? R2 dot,
C3.
so you have to be pretty smart. R2 dot,
C3.
you can simply, you don't have to actually go through all this, you just have to take R2 and you have to take C3 and fuse them. Means take the dot. Understood? The second thing what they're going to ask you, obviously in board examination they are going to ask you how to multiply, show them each other, and they give you 3 by 3 order or 2 by 2 order, which you can easily handle, right? The second thing what they're going to ask you, tell me the trace of AB. So what is trace of AB? Sigma Rn dot C, where n belongs to जो भी रोज हैं, नंबर ऑफ रोज एंड रोज कॉलम, तो ट्रेस आप तुरंत निकाल दोगे, r1.c1, r2.c2, r3.c3, cn, मतलब स्क्वायर मैट्रिक्स का ही आपसे पूछा जाएगा. अंडरस्टूड नॉट अंडरस्टूड? क्लियर? A23 ऑफ AB एंड ऐसे क्वेश्चन पूछा जाएगा कॉम्पिटिटिव एग्जाम्स में. बोर्ड एग्जामिनेशन वी कैन नॉट हेल्प इट, बट 5 मिनट का कॉन्सेंट्रेशन विल गिव यू फुल मार्क्स. इतना तो बोर्ड्स में फिक्स है ना. और IIT JEE के एग्जाम में they are not going to take ये क्या हो रहा है, they will simply ask tell me the few elements of the product. The second thing what they are going to ask you, does BA exist? AB तो हो गया, क्या BA exist करेगा? हमेशा करेगा, कभी करेगा, और depends. Depends. What's the dependence case?
M is equal to Q.
So no, Q is equal to M. So I am going to put this way and this way. So first we are going to see कि Q is equal to M. अगर Q is equal to M हो गया है तो एग्जिस्ट कर रहा है AB BA. क्या AB और BA का ऑर्डर सेम होगा? नॉट नेसेसरी, नॉट नेसेसरी. कब होगा सेम ऑर्डर? देखो AB का ऑर्डर क्या निकल के आया, कितना रोज आया, कितने रोज हैं? यू हैव n रोज, और हाउ मेनी rows you have? M rows. And how many columns you have?
Q.
So you know the order is going to be M into Q. N and P will vanish away. And what will be the, if Q is equal to M, what will be the order of BA?
P into N.
P into
N.
P into
N.
N. So you have the order M into Q and you have the order
P into
to N. When are these two equal? No. Only when all the fours are equal. All the four are
Equal.
then only BA and AB will have same order. अच्छा, अगर AB और BA same order है तो does it mean that they are equal? No, that also depends. That also depends. So few property about we understood something about the commutative property of matrices. First, generally commutative matrices are not commutative. Matrices are not commutative. We got two strong reasons. First, exist ही नहीं हो सकता है, AB है लेकिन BA exist ही नहीं कर रहा है. लेकिन अगर exist भी कर गया है तो हो सकता है order ही नहीं सेम हो, और अगर order भी सेम हो गया है तो हो सकता है equal हो या ना हो. मतलब they have to go through these steps, then only we can say whether they are equal or not equal. And when they are equal, we have a special name for these two matrices. We call them commutative matrices. So generally the matrices do not follow commutative property, but if they follow, what do we call it? Commutative. और commutative ऐसा नहीं है कि AB और BA दोनों exist कर रहा है और same order का है तो commutative ही होगा. No, every entry has to be same. Then only we can say they are equivalent. Okay. So first thing, matrices are not commutative in nature, but sometimes they are. Sometimes आप ये तीनों steps लिखो कि commutative matrices are not commutative in nature. Matrices are not commutative. Multiplication properties में लिखना. Matrices are not commutative. Case 1 लिखना. If AB exists, then there can be two cases, whether BA exists or BA does not exist. So if AB, सबसे पहले तो AB exist करना चाहिए, तभी हम बात करेंगे. AB या BA में से कोई एक exist करना चाहिए. अगर A मतलब A and B are like changing thing, no? So AB exist कर रहा है तो फिर दो cases emerge करेगा. BA either exist कर रहा है या नहीं कर रहा है. सो बी ए जब एग्जिस्ट नहीं कर रहा है वी आर नॉट गोइंग टू टॉक अबाउट इट. और जब बी ए एग्जिस्ट कर रहा है तो फिर दो केसेस हो गए, उसके ऑर्डर सेम है या सेम नहीं है. अगर ऑर्डर सेम नहीं है तो फिर कोई बात करने की जरूरत नहीं है, और अगर ऑर्डर सेम हो जाता है तो फिर से दो केसेस बनेंगे, दे आर इक्वल और नॉट इक्वल. एंड इफ दे आर इक्वल, इस रिलेशनशिप को कहेंगे कॉम्यूटेटिव मैट्रिसेस. we'll see some examples where matrices are commutative, and we'll keep making notes कि okay, these type of matrices are commutative in nature. Okay, matrices are associative. Yes, matrices are associative. We can play with the bracket, but we should not play with the order. Matrices are associative in nature. Take two diagonal matrices. What is a diagonal matrices? Square matrix whose all elements are 0 except for the diagonal. So take two diagonal matrices and check whether they are commutative or not. And if yes, they are commutative, make a note that two diagonal matrices are always commutative. How are you going to check that two diagonal matrices are commutative or not? पहले एक matrix ले लो 3 by 3 का, right? So matrix A is, let's say, P Q R, and matrix B is L M N. So what is AB going to be? PL QM RN. And what is BA? Same game. So are the entries equal? So yes, two diagonal matrices are. I hope everybody got it, or should I have to explain it? How did we got the answer? है ना, आप रो को कॉलम को करेंगे तो बाकी सारे बंदों के पास तो जीरो है ना, सारे एलिमेंट्स ही जीरो हैं. रो 1 डॉट C1 रो आपको पता है कि यू नीड ओनली डायगोनल गाइस, क्योंकि बाकी तो सारे वैनिश अवे हो जाएंगे. सो R1 डॉट C1, R2 डॉट C2 एंड R3 डॉट C3. जस्ट अ simple calculation in the head and you will get your answers. So you can say two diagonal matrices are always commutative. A square matrix and identity matrix are commutative in nature. So AI is equal to IA. I is capital I is usually denoted for identity matrix. So AI is equal to IA. Even a to the power m is into a to the power n is equal to a to the power n is a to the power m into a to the power n is equal to a to the power n. This is also commutative. This also display commutative nature. Means a to the a square into a cube is equal to a cube into a square. Understood? Then also it shows commutative nature. We'll explore more about commutative property further. Okay, so if you want to write a to the power 5, you can write a to the power 5 is equal to a square into a cube, or a cube into a square, right or wrong? A square would be some different matrices, let's say C, and a cube would be some different matrix D. So I can say C and D are commutative in nature. Clear? Okay, now coming to the next very important terminology of matrices called transpose. What is transpose? आपके पास ये मैट्रिक्स है, लेट्स से 4 into 3, so you have 4 rows और 3 columns. So you have 4 rows and 3 columns. So this is 4 by 3. If I call this as matrix A, इसके ट्रांसपोज को डिनोट किया जाता है ए पे टी, ए डैश या ए पे लिखा हुआ है टी, ए टू द पावर टी या ए डैश। तो इसका ऑर्डर सबसे पहले बताओ क्या हो जाएगा,
4
3/4। सो एवरी रोज विल बिकम
columns
कॉलम। सो
A11 A12 A13 A21 A22 A23 A31 A32 A33 A41 A42 A43 3/4
बट A11 यहाँ से लिया जा रहा है, ये A21 नहीं है, ये A12 ही है इस एलिमेंट का, है ना, ये ध्यान में रखना। ओके क्लियर। सो ट्रांसपोज निकालना आता है। सो एवरीबॉडी अंडरस्टैंड व्हाट आर ट्रांसपोज मैट्रिसेस, व्हाट आर द प्रॉपर्टीज ऑफ ट्रांसपोज मैट्रिसेस। सिंपल है, बेसिक डेफिनेशन है कि नंबर रोज और कॉलम इंटरचेंज हो रहे हैं और कुछ नहीं हो रहा है, मतलब जो ऐसे था वो ऐसे हो गया है। सो वी जस्ट ट्विस्टेड देम, वी हैव जस्ट 90 डिग्री हमने उनको टर्न कर दिया है। इफ दिस इज रेक्टेंगल, आप इसको टर्न कर दोगे तो क्या हो जाएगा, ये हो जाएगा ना। यू जस्ट स्ट्रक्चर को, सिंस यू हैव टू ऑलवेज कीप इन माइंड दैट मैट्रिक्स इज अ स्ट्रक्चर, दिस विल हेल्प यू टू थिंक। सो आप ट्रांसपोज कैसे करते हो, आप ऐसे कर देते हो, जस्ट टॉपल देम। ओके, एंटी क्लॉक ऑब्वियसली। नाउ क्लियर। पहली प्रॉपर्टी है ए ट्रांसपोज ऑफ ट्रांसपोज। ए प्लस बी का ट्रांसपोज, ट्रांसपोज विल बी सेपरेट, विल बी distributed. Of course, if A plus B has to be of same order, and that I don't have to explain every time, right? Now tell me what is A B का transpose.
B transpose into A transpose.
Okay, you can prove it through simple multiplication, है ना?
Yes sir.
Okay. What is the mod of 80? Mod means det of 80. Determinant of 80 क्या होगा? मैंने बोला था ना जब आप लोग क्लास 11th में थे, तो एरिया निकालने के जब बोला था तो मैंने बोला था कोई भी कॉलम या कोई भी रो चूज कर लो, डेट चेंज नहीं करेगा। विल अंडरस्टैंड दैट इन प्रॉपर्टीज ऑफ डेट विल बी डीलिंग माइनर्स एंड cofactors. Okay, so for a timing you can simply keep in mind that det of A transpose equal to det of A, and det of AB is equal to det of,
A into delta of
okay, mod वाली प्रॉपर्टी जो कॉम्प्लेक्स नंबर में पढ़ी थी, it will work here also. So let's do two questions. So you have a matrix P, right? You have a matrix.
P.
I usually, for matrix, I usually put a curly thing, and for determinant, I put a straight thing. Okay. तो obviously आप काफ़ी बीच में काफ़ी ज़्यादा matrix and determinant को handle करने लगेंगी, तो अगर आप इस टाइप का differentiation नहीं रखिएगा तो you'll get confused sometimes. So always try a practice of giving structure a curly shape and
Determinant.
find this matrix P transpose into Q to the power . So what are you going to do? जल्दी बताओ, we don't have much time.
Sir, 10 A to the power 2010.
A to the power?
2010.
Very good. And what's A to the power 2010?
1.
देखो a स्क्वायर तो पहले निकाल के देखो, a स्क्वायर निकाल के देखो, a क्यूब निकाल के देखो, you will get the idea. देखो a क्यूब क्या आ रहा है, अब समझ में आ गया होगा क्या आएगा बताओ. A to the power, A to the A1.
2010 01.
गुड. और से नेम?
रुचिका.
रुचिका. काफ़ी दिन हो गया तुमसे बात किए हुए. ओके, समझ में आ गया. ओनली रुचिका is able to solve this question. Why? Nobody is getting any clue. See, when you see q to the power 2010, you're just going to make sense that this is going to fit in here, right? If you see P transpose into PAP transpose into PAP transpose into PAP transpose into P. Okay. Now, since we know it is associative in nature, right? So we can shift, we can do little playing with the bracket. So I can redefine every story as understood? And we know the P and we know P transpose. If you see P into P transpose, that will result in identity matrix. That will result in identity matrix. देखो ना, आप इसको ट्रांसपोज ऐसे कर दो. So you are going to make it half, and you're going. If you take a dot, you will see it's turning out to be identity matrix. ये अगर आप बहुत सारा, obviously it's an IIT question और आपको लग रहा होगा कि आपको कैसे click करेगा, but when you are actually doing lots of multiplication, you will realize these type of things. Root 3 by 2, root 3 by 2, it's a trigonometric thing. It's a trigonometric thing. Sine 60, cos 60, cos और minus cos 60. And you know it में प्लस हो जाता है, तो आपको कहीं ना कहीं हिंट आ जाएगा कि ये 1 है. ठीक है. सो इट्स लॉक. आप अभी एक्सपेक्ट नहीं कर सकते कि आपको अचानक से क्लिक कर जाएगा, बट विथ एक्सपीरियंस यू कैन एक्चुअली अंडरस्टूड, बिकॉज आप डॉट ही तो ले रहे हो, है ना. एंड दे विल एड अप टू 1 बिकॉज साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा इज ऑल्सो 1. ठीक है. तो यहाँ से निकल के आएगा 1 हो जाएगा, आई हो जाएगा और ये हो जाएगा. आई ए कितने तक? 2010 बार, क्योंकि लास्ट वाला आई ए अलग सेपरेट कर जाएगा, क्योंकि आई नो कितने ए है मेरे पास, 2010 ए है मेरे पास. तो ये तो आई अपना अलग रह जाएगा. तो वी आर नॉट इंटरेस्टेड इन आई, एंड ए आई एक्चुअली इज ए, एंड ए इंटू ए हाउ मेनी टाइम्स? 10. एंड ए इज़ अ वेरी ब्यूटिफुल मैट्रिक्स. वाई? इफ यू सी ए स्क्वायर क्या हो जाएगा? दिस डॉट दिस इज 1, दिस डॉट दिस इज 2, this dot this is 0, and this dot this is 1, and the process will keep continuing. So a to the power n would be 1 and 1, and 2010 would be
2010 01.
understood? Clear? इस तरीके से सोचेंगे. Okay, do one more question. Determinant a cube is, okay, you know ना determinant 2/2 का determinant निकालना आता होगा. इनफैक्ट 3/3 का भी आता है ना, हम निकाला था. कोई भी एक रो चूज कर दिया एंड देन वी असाइन प्लस माइनस प्लस. विल मेक वाई इट इज डूइंग दैट लेटर ऑन, बट मैकेनिकल अप्रोच यू नो हाउ टू फाइंड इट. और 2/2 का बहुत ही आसान होता है. दिस माइनस दिस. व्हाट इज डेट ऑफ ए क्यूब? वुड बी डेट ऑफ ए का क्यूब. डेट ऑफ ए क्यूब वुड बी cube of det A. So I can write, so I can say mod A is
5.
so alpha is
3.
why you are saying 3 plus minus 3. Don't say this type of thing. Okay, now coming to two very important terminology. One is called symmetric matrix and the other is called,
Skew symmetric matrix.
what is symmetric matrix?
Transpose A transpose equal to A.
Okay, and what does it mean in basic sense? आंखों को देखते हैं वो क्या दिखता है? How do we say it's symmetrical?
All the elements rows and columns.
सबसे पहले तो स्क्वायर मैट्रिक्स होना चाहिए. A12 is equal to, हाँ मतलब कैसा दिखता है वो? Diagonal is the mirror. Diagonal is the
Mirror.
principal diagonal is the mirror. Whatever you see, diagonal का element is not a contention, है ना? So symmetric matrix is simply diagonal से जैसा left नीचे दिख रहा है, मतलब upper triangular और lower triangular के elements same है ना? upper triangular portion और lower triangular portion के, और diagonal पे कुछ है? diagonal का कोई specific elements है या कुछ भी हो सकता है? आपने अभी कहा ना A ट्रांसपोज इक्वल टू A, तो जब ट्रांसपोज लेते हो तो A11, A22, A33 रिमेन्स अनअल्टर्ड ना, तो डायगोनल कुछ भी हो सकता है. यू जस्ट हैव टू सी कि डायगोनल का नीचे और डायगोनल का ऊपर सेम होना चाहिए, मतलब डायगोनल इज एक्टिंग लाइक अ मिरर. देन ओनली वी कैन से सिमेट्रिक मैट्रिसेस. व्हाट आर स्क्यू सिमेट्रिक मैट्रिसेस? It's more like odd function and even function. Even functions are symmetric and odd functions are skew symmetric. Okay, what's the story of skew symmetric?
Minus on A.
Okay, so you want to say that all the elements of upper triangle has to be negative of the,
Lower triangular.
jab, or lower triangle has to be negatives of.
Upper triangular.
Can you say anything about diagonal matrix? They all are equal to 0. Why? डायगोनल मैट्रिक्स में A12 नहीं होता है. A11 is equal to minus A11. A11 is equal to minus A11. A11 is equal to minus A1, which means 2A11 is equal to A22 is equal to minus A22, which means 2A22 is equal to 0. A33 is equal to minus A33, which means A33 is equal to 0. Understood? So skew symmetric matrices में diagonal सारे 0 होंगे. ये inference है आपका. Don't put it in a definition, but something like you know it. One of the property, जैसे rhombus के diagonals bisect करते हैं, आप definition में नहीं डालते rhombus के, right? Rhombus के definition में सीधे आप बोलते parallelogram all sides are equal. So similarly matrix के definition में skew symmetric में you will say A transpose is equal to minus A, which itself means that the principal diagonal is going to be 0, which you can easily prove it. एंड लोअर ट्रायंगुलर में जो भी बंदा है अगर 3 है तो उसका पार्टनर, अगर A21 3 है तो A12 शुड बी -3, A32 अगर -4 है. अंडरस्टूड? क्लियर और नॉट क्लियर? सो यू अंडरस्टैंड ट्रांसपोज, यू अंडरस्टैंड सिमेट्रिक मैट्रिक्स, यू अंडरस्टैंड स्क्यू सिमेट्रिक मैट्रिक्स. गुड. Det of Ka would be equal to det के फॉर्म में यहाँ से बताओ. Give me, express this in form of k to the power what is n? Order of the square matrix. Understood or not understood? Everybody got it? अगर 3 by 3 का है and if you are multiplying each element by 3, so the det of A would be multiplied by, of course, everything. If I am a guy of 5 components and every component adds on to my value and I am multiplying each component by 5, it means the whole story has multiplied by 5 to the power 5, because my every component is contributing something to the value of my. ठीक है? And I hope everybody understand what is k into det A. है ना? Because det A is nothing but a number only, a scalar quantity. And what happens when you multiply a scalar with scalar? You get another scalar. So you just have to multiply k with one of the row or one of the column, whatever you want to put. But the det is going to be only, if det is 7, then 5 det A would be equal to 35. और ऑर्डर में अगर 5a का डेट निकाल रहे हो तो इट हैज टू बी 5 टू द पावर n. Okay, just prove me that det of a skew matrix would be 0 if it is an odd, if the order is odd. You have to prove that det of a skew matrix, skew symmetric matrix, would always be 0 if it is of order n. By just looking at the matrix you can say whether it is a skew symmetric or not, right? And if तो आपको प्रूफ करना है कि ऑर्डर अगर इसका ऑड है, मतलब अगर ये 3 by 3 मैट्रिक्स है या 5 by 5 मैट्रिक्स है या 7 by 7 मैट्रिक्स है, just by looking at it you, मतलब you know it that the det is going to be 0. You have to prove that.
And if at all we are calculating the
Go to the basics. Skew symmetric, go to the basics. What is the skew symmetric story? A transpose is equal to minus A. And I told you, and go to the basics of the properties of transpose. What did I say about the mod of A is equal to mod of A transpose? And I said A transpose is equal to minus A. And if you are going to take the det both side, and this is an n order, so what's going to be the det of minus A? Minus 1 to the power odd into det A. What is minus 1 to the power odd? So det A is equal to minus det A, which means 2 det A is equal to 0, which means det A would be equal to 0. समझ में आया? If you are unable to think anything, you have the keywords and you have already, अगर आप एग्जाम में जा रहे हो तो you have already marked the basics. So those basics needs to be here. Do this practice. Whenever you are doing some questions, let's say related to straight line, coordinate geometry, draw a flow chart first. Don't directly jump into the question if you're practicing. Draw a flow chart. starting with a straight line story, starting with abscissa and ordinate, going through whole story in one big chart paper, the whole thing, and paste it in front of it, and then solve the questions. And when you get stuck, look at those posters and look specifically कहाँ पे देखना है. If you keep doing that process, within 10-15 days you will not realize that chart paper. That chart paper will अपने आप आंखों के सामने इमर्ज होगा. That is the key of problem solving skills. प्रॉब्लम सॉल्विंग स्किल कहीं पैदा नहीं होके आता है या कोई टीचर समझाता नहीं है, वो हो ही नहीं सकता, ये अपना होता है. बट व्हाट हैपेंस व्हेन यू आर सॉल्विंग, यू जस्ट हैव टू टॉक टू योर ब्रेन. अभी जैसे क्वेश्चन आता है तो आप क्या करते हो, आप याद करने की कोशिश करते हो, कुछ भी करने की कोशिश करते हो, ट्राई टू गेट इन्फॉर्मेशन, और सारे इन्फॉर्मेशन बेसिक्स में होते हैं. सो यू शुड बी एबल टू ट्रेस द स्टोरी इन योर हेड इन फ्रैक्शन ऑफ सेकेंड्स. क्योंकि तुम्हारे को क्वेश्चन आया है, लेट्स से मिरर इमेज का क्वेश्चन आया है, तो सीधे मिरर इमेज पे स्ट्रक कब करोगे, जब तुम्हें ये रास्ता ऐसे ऐसे करके चलाना आता है, तब तुम सीधे मिरर इमेज पे जाओगे और फिर क्वेश्चन आंसर सॉल्व करोगे. अगर तुमको मिरर इमेज अब ऐसे कर क्या होगा, अगर तुम इस प्रोसेस को नहीं किए हो तो व्हाट विल हैपन, तुम सोचोगे मिरर इमेज, मिरर बना के, एंड देन यू विल गो इनटू द बेसिक. दैट इज आल्सो द बेस्ट अप्रोच, बट दैट विल बी स्लोअर देन दोज. ओनली दीज टू अप्रोचेस विल हेल्प यू सॉल्व. लेकिन आप लोग का अप्रोच क्या होता है, याद करने की कोशिश करते हैं, स्ट्रेस ले लेते हैं, यार भूल गई हूँ मैं, ये कर ली हूँ वो कर ली हूँ, तो फिर उसके बाद यू आर नॉट एबल टू डिराइव द रिजल्ट. कोई भी चीज़ याद नहीं किया जाता है, हर चीज़ को बेसिक्स ध्यान में रखता है. बेसिक्स से अपने आप पता चल जाता है कि व्हाट शुड बी द नेक्स्ट लॉजिकल स्टेप, व्हाट शुड बी द नेक्स्ट लॉजिकल स्टेप. अभी मैंने आपको सिंपल बोला था स्क्यू सिमेट्रिक मैट्रिक्स. स्क्यू सिमेट्रिक मैट्रिक्स सुनते ही आपके आंखों के सामने क्या इमर्ज होगा, और ट्रांसपोज की प्रॉपर्टी अपडेट की बात हो रही है, राइट? तो तुम्हें ये तुरंत इमर्ज करेगा. सो यू आर जस्ट गोइंग टू टेक द नेक्स्ट स्टेप. मैं बार बार एन ऑड है पे फोकस कर रहा हूं, ये आपको पता चल गया. और आपको पता है माइनस के माइनस ए टू द पावर का डेट क्या होता है, so you simply say minus, solve. Even those people who haven't read this property can think spontaneously during the class, during the exam. So you do the flow chart, जैसे हम लोग रिवीजन करते हैं ना, वो फ्लो चार्ट, सारे रिजल्ट्स, की पॉइंट्स, वो माइंड मैप आपके आंखों के सामने होगा. एंड वेन एवर यू आर सॉल्विंग क्वेश्चंस रिलेटेड टू दैट, कीप दैट हैंडी इन फ्रंट ऑफ योर आइज. और इस तरीके, और जब तुम उसको कलरफुल स्केच पेन से बनाओगे स्ट्रेस को, तो वो तुमको और मतलब यू विल बी पुटिंग टोटली इंटरेस्ट इनटू इट. एंड व्हेन यू आर पुटिंग इंटरेस्ट इनटू इट, इट बिकम्स योर ओन थिंग. एंड व्हेन यू स्टार्ट ओनिंग थिंग्स, सर्कल का चैप्टर कितना है, फुल ऑफ रिजल्ट्स. सर्कल चैप्टर इज फुल ऑफ रिजल्ट्स, और उसको अगर तुम ओन कर ली तो तुम्हारा 2 डिग्री ख़त्म हो जाता है. तुम्हारा हर पोर्शन से 40-50% अपने आप मैनेज हो जाता है, चाहे वो पैराबोला हो, एलिप्स हो, हाइपरबोला हो. फिर स्पेसिफिक्स में चले जाओ, पैराबोला के टी रिजल्ट्स में. टी रिजल्ट्स भी छोटे से हैं, बट यू हैव टू नो कहाँ से शुरू हो रहा है, कहाँ पे एंड हो रहा है. प्रॉपर्टीज़ ऑफ ट्रायंगल हमने 27 प्रॉपर्टीज़ की थी, कहाँ से शुरू हो रहा है, कहाँ से. एक जब हमारे आँखों के सामने होगा तभी तुम एग्ज़ाम में प्रोड्यूस. एग्ज़ाम में नॉलेज टेस्ट नहीं हो रहा है, एग्ज़ाम में नॉलेज टेस्ट नहीं हो रहा है, एग्ज़ाम में आपकी स्पॉन्टेनिटी टेस्ट हो रही है, आपकी स्मार्टनेस टेस्ट हो रही है. आपकी स्मार्टनेस, आपकी स्पॉन्टेनिटी ही बताएगी कि वेदर यू विल बी एबल टू excel in the field of sciences or not, in the field of economics, in the field of mathematics or not. तो वो चीज़ का एग्जामिनेशन होता है. and they want the best because too many people chasing too few seats. okay, तो ये सारे प्रोसेस जब तक इनकलकेट नहीं करोगे, you will fall flat even if you know the whole topics. understood? Because there are so many topics. you have seen, you must be thinking that you have forgotten class 11th, right? ऐसा फीलिंग आ चुका है, अक्टूबर तक आ जाएगा और लगेगा कि मैं रेस से बाहर हूँ. उस वक्त जो रिटेन कर जाता है वो निकाल लेता है. Prove that every square matrix can be expressed. Prove that every square matrix can be expressed as a sum of symmetric and skew symmetric matrices. I hope everybody got the question. Prove that every square matrix can be expressed as a sum of symmetric and skew symmetric matrix in a unique way. Or you have to say represent A. अगर आपके पास matrix A है, then you have to represent skew symmetric plus skew symmetric unique way. So I just gave you a general form. इस type के questions particular आएंगे तो you can solve it, right? इस form को solve करो पहले. फिर क्यों मान लिया मैट्रिक्स? ये तुम कभी तभी निकाल पाओगे, मतलब ये चीज़ तुम तभी स्टेप फॉलो कर पाओगे जब तुम्हें आंसर पता है ना? तुम्हें जब आंसर पता है तभी तुम ऐसे लिख पाओगे, लेकिन ये आंसर आता कैसे, दैट इज़ द होल थिंग. तुमने जो a प्लस ए ट्रांसपोज बाई टू और a माइनस ए ट्रांसपोज बाई टू लिखा है, ये आया कैसे तुम्हारे दिमाग में, दैट इज द क्वेश्चन. समझ रहे हो? एंड देन अगेन यू हैव टू गो इनटू द बेसिक्स. व्हाट्स द बेसिक्स? a is equal to b plus c, which means you understand that b is a symmetric and c is a. The question is what is B and C? That is the whole question. Now again you are going to take the A transpose is equal to B transpose plus C transpose. And what is B transpose going to be? B. And what is C transpose? So the idea is to get B and C. Now you got two equations, add them. Subtract it. So what is B?
Half of a minus a plus a transpose.
So this is the way you are going to write A plus A transpose by 2, which is going to be a symmetric matrix, and A minus A transpose by 2, which is going to be skew symmetric matrix. This is how you are going to write your any matrix in a unique way as a sum of. It's a very standard question. They give you the question, they give you the matrix and ask you to write in two forms, skew plus symmetric. Now symmetric plus skew में आप कैसे, you don't have to put every time this thing, you simply say A plus A transpose by 2 and A minus A transpose by 2. A plus A transpose by 2 is the symmetric part and A minus A transpose by 2 are the skew symmetric part. Now come very strong concept and where students really get confused, and that is inverse of a matrix. What is inverse of a matrix? When do we call two matrices are inverse to each other? Okay, so when I say AB is equal to BA is equal to I, which means AB is equal to BA is equal to I. What can I say about A and B? And what else we can say about it? They are commutative. So inverse and the matrix and if its inverse exists, matrix and if its inverse exists, then they are commutative in nature, and A into A inverse is equal to A inverse into A is equal to I. But sometimes we see that the inverse doesn't exist, like you have numbers, which number inverse, multiplicative inverse does not exist? 0. Similarly, you have matrices whose inverse do not exist. Those matrices are No. Null matrix is one of them. Those matrices are whose debt is equal to 0. And what do we have a special name for those matrices?
Singular matrix.
Singular matrices. So if the debt is 0, it means the inverse does not exist, which means it's a singular matrices. And if the inverse exists, we call it non-singular matrices. Okay? So inverse may or may not exist, right? Few properties of inverses. A into A inverse is equal to I, right? Or you can say A inverse into A, I. Now I know mod of A inverse is equal to 1, which I can say mod of A into mod of 1, which means mod of if okay, if mod A is equal to 0, then A inverse is, sorry, A is similar matrix and A inverse does not exist. Understood? अगर इन्वर्स एग्जिस्ट कर रहा तो के ए का इन्वर्स क्या होगा? वन बाई के ए इनवर्स. ओके, अगर इनवर्स एग्जिस्ट कर रहा है, अब मैं जो भी प्रॉपर्टी कर रहा हूँ, वी आर अज्यूमिंग दैट इट्स नॉट अ सिंगुलर मैट्रिक्स, इट्स अ नॉन सिंगुलर मैट्रिक्स. ए इनवर्स का इनवर्स क्या होगा? ए. ओके, ए ट्रांसपोज का इनवर्स क्या होगा? ए इनवर्स का ट्रांसपोज. ओके, एंड ए बी का इनवर्स क्या होगा? Which you can easily prove it through multiplying with the guys. Okay? Understood? So these properties need to be kept in head. So I'll just ask 2 questions and then we'll go further. I'm just going little fast, I know, because we'll be able to finish the major chunk of matrices and little bit of determinant. Okay, should I have it? This chapter needs lots of practices and all, which you are going to do it at your place. And the only thing you need, why you need so many practices in this, because you are pretty new to this structure. You are familiar to numbers since class 1, but you are not familiar with structure, at least dealing with structure. So that is why it becomes little more new to things. That is why you find little difficult. Okay. So इतना तो idea लग गया होगा. It's more about exposure. A is given as 1, 2, 3, 4, and fx is given as x square minus 5x plus 6. You have to first find f of A. Okay, find f of A, then find A inverse in terms of I and A. Everybody understand what is I, right? Identity matrix. And A, it's already given. Now first you have to find this. देखो you got a very beautiful way to find A inverse, है ना? You know what is fx? That is x minus 2 into x minus fx is x minus 2 into x minus 3. Then what would be fa was going to be? Oh, you're going to find a square. You don't have to. See, fx is x minus 2, so fa is going to be a minus 2 कहना गलत है, a minus 2i. What is a minus 2i into a minus 3i? Solve it. क्या? 800 8i. So you got 8i. So you know fa solve, but तुम्हें लगता है fa solve करना था? इनवर्स, ये तो क्वेश्चन था ही नहीं. क्वेश्चन था a स्क्वायर minus 5a plus 6i is equal to 8i. Right, this is the equation we got, and using this equation we are going to derive A inverse. So I'm going to write this story as a square minus 5a is equal to 2i. Now I am going to multiply both sides by A inverse. So I can say, okay, just tell me det exist करता है कि नहीं करता है. So A inverse में multiply किया, since commutative nature है, so we can be little careless about the order because we know inverse and the guy is commutative and then identity matrix and the matrix are commutative, so we can be little careless here. But generally we are not going to be careless when multiplication of matrices. We have to be very particular about the order. तो क्या हो गया? A हो गया ये, और ये क्या हो गया? So can we find A inverse now? Just by simple mean. Okay, next question. If matrix A to the power 5, मतलब capital A to the power 5, if capital A to the power 5 is equal to 0, if capital A to the power 5 is equal to 0 and A to the power n, capital A to the power n is not equal to 0 for n is equal to 1, 2, 3, 4. मतलब समझ में आया? A to the power 5 is 0, but a square, a cube and a to the power 4 are not 0. Find I minus a, bracket में I minus a, put it in a bracket, to the power minus 1. I minus a to the power minus 1 in terms of I and A. So this way we are trying to find inverse in using equation and then using the concept of commutative property of exploiting the multiplication part of both, right? So now the question is I to the power 5, A to the power 5 is 0 and A1, A2, A to the power 3, A to the power 4, they are not 0. You have to express your I minus A inverse in terms of I and A. How to go for it? हो गया? You know I to the power 5 is 0. Minus A to the power 5 would be, and I to the power 5 would be I. सुना? x to the power n minus y to the power n क्या होता है? x minus y, या x to the power n minus 1 क्या होता है? x minus 1 into 1 plus x plus GP में ही पढ़ा था हमने. Okay, now here the click. Why are we careless about the commutative property? Because I know I'm just dealing with A and I's. When I'm dealing with A and I can be little careless with the commutative properties, right? That is why we pointed out some of the are commutative in nature, so that algebraically we can play on. Now I have to find inverse of this guy. So what should I do? Multiply both sides with I minus A inverse. I minus A inverse into I minus A is equal to the same guy is equal to I minus A inverse into I, which is same, and this will be 1. So what's the answer? This was our answer. or you can say these two matrices are multiplying to give me the identity matrix. So इसका inverse यही होगा ना, या इसका inverse ही होगा. Understood? Such an easy question. Tell me, matrices A plus B का whole square क्या होगा, matrices A minus B का whole square क्या होगा, और A square minus B square क्या होगा. हाँ, how to handle A plus B का square? हाँ, how to handle matrix A plus B का square? We can be little careless with A square B square, but not with and when they are commutative we are going to set to AB, else we are going to leave the answer as it is. So I don't have to write. When it is commutative it is going to be 2AB. आप बताओ. minus AB minus B. What is A square minus B square? Huh? Sorry. What is A plus B into A minus B? बताओ. A square minus B square if they are commutative, and if they are not commutative, what will be the answer? A square minus AB plus BA minus B square. And if they are commutative, they will cancel out each other, right? Okay. And similarly, you can find A plus B cube. You are not going to just, if they are commutative, straight away go, है ना, जो आप बचपन से पढ़ते आ रहे हो. And if they are not commutative, be careful with the multiplication. Addition में commutative होता है, that's okay. You have an M matrix, which is a 3 by 3 matrix, and det of M is 1, and M into M transpose is an identity matrix. Okay. You have to show me that det of M minus I is 0. The second question is A is a 3 by 3 matrix, already given the entries, right? And you have to find me the scalars such that A cube plus PA square plus QA plus RI is equal to 0. PQR are not matrices, PQR are scalars. हाँ सॉल्व कर लिया गुड तुमने ऑलरेडी कर रखा है क्या चैप्टर कहाँ से किया था ये क्या कर दिया
उसका डेल्ट लिया आई का डेल्ट 1 होगा और एम इंटू एम ट्रांसपोज आइडेंटिटी होता है वो मेरे पास बना गया फिर सबट्रैक्ट करा तो 0 आ गया और जैसे अगर एक में होता है तो डिवाइड हो जाता है तो 2 को एक में कर दिया तो जैसे अगर हमारे पास डेल्ट ऑफ एम माइनस आई होता है तो उसे हम डेल्ट एम माइनस
नो ट्रायंगल इनइक्वालिटी को तुमने अब्यूज कर दिया mod of A plus B is not equal to mod A plus mod B. Who has told you that? जब हमने कॉम्प्लेक्स नंबर किया था तो मैंने प्रॉपर्टीज ऑफ मॉड में क्लियरली कहा था जब हमने बेसिक मैथमेटिक्स की क्लास की थी तो हमने क्लियरली कहा था mod A triangle inequality sum of two sides will always be greater than the third side. You cannot say that. Use only those property you know. Don't create your own property. See, I know I is equal to this and I have to prove this is equal to 0. So I'll start from the left side. क्या हुआ? तो फिर क्या होगा? हाँ क्या इंट्रोड्यूस हो जाएगा क्या बोल रही हो क्या दिखाओ दिखाओ क्या कह रही हो
उसके बाद ये इससे ये दे जाएगा उसके बाद हमें ये दे रखा है तो ये बन हो जाएगा और एम ट्रांसपोज हमारा जो मॉड में होता है वो ये होता है दोनों तरफ आई सब्ट्रैक्ट कर दें
ये कैसे तुमने कह दिया एम को आई एम आई है क्या
सर एम माइनस आई
हाँ तो एम
जैसे मॉड के अंदर नहीं होता
तुम m माइनस आई को तुम कहना चाह रही हो मॉड कचड़ा माइनस कूड़ा इज मॉड कचड़ा माइनस मॉड कूड़ा है प्रूफ करना है तो कैसे भी कर दो we'll start with the right hand side that is the first step m minus m transpose which is m minus I we start with right hand side so I is can be written as
m into m transpose
which I can write which I can write understood mod m क्या है 1 so I can write minus 1 into m transpose minus I ठीक है minus 1 to the power n. M transpose minus I. Minus 1 to the power odd क्या है 3/3 minus m minus I to the power transpose. I का ट्रांसपोज तो I होता है ना, which is equal to minus, which means twice of m minus I is. देखो हमेशा बेसिक प्रॉपर्टी ट्रांसपोज की प्रॉपर्टी को हैंडल करना सिखा रखा हूँ. अब यहाँ पे आके मेनी पीपल कैन फील ब्लॉक्ड कि आप क्या करो. अच्छा ऐसा कोई प्रॉपर्टी होता होगा कि m ट्रांसपोज माइनस 1 इज इक्वल टू, ऐसा कुछ नहीं है. यू हैव टू नो दैट यू हैव टू प्रूव m माइनस आई. सो यू जस्ट हैव टू थिंक m माइनस आई का ट्रांसपोज है ये, एंड देन द सेकेंड प्रॉपर्टी यू यूज द डेट ऑफ ट्रांसपोज इक्वल टू इट्स डेट. So m minus I transpose is actually equal to m minus I. So m minus I is equal to minus of m minus I, which means twice of m minus I is equal to 0, which means m minus I is 0. Okay, try second part, second question. समझ में आया? क्या हो गया? कहाँ से आपने स्टार्ट किया? ठीक है, आपने m बाहर निकाला, वेरी गुड. माइनस 1 टू द पावर n कर दिया, गुड. आगे नहीं समझ में आया. m ट्रांसपोज माइनस आई है, इट इज़, हमें m माइनस आई निकालना, और इसमें कोई ऐसा प्रॉपर्टी हमें नहीं पता है. बट आई नो दिस इज़ नथिंग बट m माइनस आई का ट्रांसपोज. आई का ट्रांसपोज आई ही होता है, आई का ट्रांसपोज आई ही होता है, और आपको पता है ट्रांसपोज बढ़ जाता है. So you can say minus 1 to the power 3 into m minus I का transpose, and you know det of A and det of A transpose are equal. So you can say twice of ठीक है. What about the second part, second question? You have given the matrix, find the scalars. Now you see A and then you see cubic equation. How to handle it? 3/3 matrix, and then you are going to write. Of course, I won't ask you to put here and do all this thing which you don't want to do. We have a special tool to solve these type of problem, and we call it characteristic equation. What is characteristic equation? Have you heard this term, characteristic equation? No. See, I hope everybody understand A minus AI is equal to 0, right? So, I hope everybody understand what is the solution of this matrix. What will be the x? A, it's a simple question. x minus 3 का solution क्या होता है? 3. x minus 3 is equal to 0 का solution 3. So simple. इसका x, इसका solution क्या होगा? A. और हम जब डेट निकालेंगे दोनों साइड, तो डेट क्या होगा? This is called the dead point. Okay. So what is A minus xi? I'm using the dead symbol. So 2, 3 will be untouched. 1 would be untouched. 2, 3, 1 would be untouched. It would be 1 minus x, 3 minus x, and 2 minus x. This is the story. And this is actually equal to 0. I hope now you can create the cubic equation. Just take this as plus, minus, plus, and then you know the brackets, right? How to find the determinant. Solve this. Get your cubic.
मुझे पता नहीं है श्योर नहीं है सही है गलत है हम कर सकते हैं सॉल्यूशन मॉड एम इक्वल्स टू 1 सर माइनस वो मतलब माइनस करेंगे मॉड आई सर
ये स्टेप कैसे ले आ रहे तुम लोग? मॉड ऑफ m माइनस मॉड ऑफ i इज नॉट इक्वल टू मॉड ऑफ m माइनस i. ये स्टेप तुम लोग गलत है. मॉड ऑफ कचड़ा माइनस कूड़ा is not equal to mod of kachra minus mod of kooda. This goes against triangle inequality. Properties of mod. Mod AB is equal to mod A into mod B. Property of mod AB is equal to mod A upon mod B. But mod A plus B is not equal to mod A plus mod B. Triangle inequality, sum of two sides can never be greater. Okay, will always be greater than. That's it. So can you create a equation? Just tell me what is the cubic equation you got. Obviously it's a 3-degree story, है ना? So you'll get a cubic equation. जल्दी से बताओ which cubic equation you are getting. And that cubic equation in X will be the solution of matrix A. So if you feed capital A in space of X, that would be equivalent to 0. So that would be the cubic equation you want to find. You want to find a cubic equation in A. So you just have to see what are the coefficients of a square, a and I. Understood? So first find me the cubic equation. What? Everybody getting the same? Minus x cube plus 6x square plus 3x minus 18. कुछ गलती क्या है? देखो कुछ गलती क्या है क्या? Okay. Someone asked me online what is characteristic equation. See, characteristic equation is something which we create an equation which will satisfy my matrices which I want that to be satisfied, right? So I use the simple concept like a minus ai is 0, then I replace capital A with capital X, then I said this equation will be satisfied by matrix A. So I can say that matrix A is the solution of this equation, and when I put it in a dead form, this becomes the characteristic equation. So the polynomial equation which you will get in the dead form is called characteristic equation, which will be satisfied by capital A as well. Understood? So I hope इसको फिर ठीक करना होगा because I want positive a cube. तो इसको क्या बनाऊंगा? So I hope if I feed a, the answer thing would become a cube minus 6a square minus 3a plus 18. ये बिल्कुल वैसा ही क्वेश्चन है जैसा हम अभी कर रहे थे कुछ देर पहले इनवर्स निकालने के लिए. Now, no, I don't have to find a inverse. Question देखो ना. We just have to find p, q, r. So p is minus 6, q is
minus 3,
and r is 18. 89. कहाँ लिखा मैं? 89. The number added to a matrix doesn't make sense. So, coming to a very important part, dealing with determinants. It doesn't mean that matrices is over, but we need to introduce some important parts of determinants called minor of elements. What are minor of elements? If I have to find M, I, J, means I want to find the minor of element A, I, J. So I will be denoting it by capital M, I, J. So if I have to find midge, what I have to do? I am going to delete the ith row and the jth column. Whatever I see, that will be the submatrix, right? उसको उसका determinant निकालेंगे. The determinant of that particular guy is our minor. So I hope everybody understand what are minor. कोई ऐसा बच्चा जो नहीं समझ पा रहा है minor? So I'm just repeating it. I have to find the minor of an element. So you need an element जिसका आप minor निकाल रहे हो, and that element is Aij, जिसको हम अभी for a timing denote करेंगे capital Mij. Capital Mij is an entry, a number, and capital Mij is nothing but if you delete the ith row and the jth column. Means if I have to find M23, I have to delete the second row and the third column. So whatever the elements I am left with, उसकी det value को हम कहेंगे minor of that element. Okay? I hope everybody is clear. Now the second important term is cofactor of element. Cofactor of element is exactly equal to minor with minus 1 to the power I plus j. Minus 1 to the power I plus j. If I plus j turn out to be even, then the minor is equal to cofactor. And if I plus j turns out to be odd, then it is negative of minor. Understood? And when you have this matrix entered with all the cofactors of elements, you call that matrix as cofactor matrix. Understood or not understood? समझ में आया? Should I write it or you understood? Understood? So we understood minor of element, we understood? These cofactors will have two important properties. And this is our defining term, है ना? ये हम define कर रहे हैं ताकि जब भी determinant निकालें, we should be very sure कि यही होता है. You have an original matrix called A1, A2, or call it B1, C1. So this is your original matrix, right? And you have created a cofactor matrix of A. Cofactor matrix of A, which let's say is do I have to explain what is capital? Let's call it capital X. Let's call it. There will be confusion otherwise, right? So you have a coefficient, you have a matrix X, and then you have a cofactor matrix of X. Cofactor of matrix is constituted by minors with the proper sign. So you know this is 1 1, 2 2 and 3 3. ये जो minus exactly उसके बराबर होगा. This would be minus, this would be plus, minus, minus, plus, minus, plus, minus, plus. Okay, so alternatively plus, minus. Now you must understand, if you take this row and if you multiply with this row, what will get? Det. Delta would be equal to A1 A1, B1 B1, or 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 even we can go with column. Even we can go with sigma A1. Understood? Both are right. And any other combination will result in 0. The any other combination, this guy going with these two guys, 0. This guy going with these two guys, 0. Always remember these two strong properties. If you multiply the elements of row or column with the cofactors of another row or column, the sum of products will be 0. So I hope everybody understand cofactor matrix. Now we are going to introduce a very important term called adjoint matrix. What are adjoint matrix? You have found the cofactor matrix, and if you take the transpose of this, you will get adjoint. My question is, what is okay? A and A adjoint of A, they are commutative. They are, which you are going to find right now. Tell me what is A into adjoint of A. A into, and it's a very important result. So you got another case where matrices are commutative. Adjoint and the guy. The guy and its adjoint, they are commutative. Tell me what is A into adjoint of A or adjoint of A into A. Why are you taking so long? We have already given you two important properties. Those two important property will help you because cofactor matrix को आप transpose ले रहे हो तो आपको समझ में आ गया है जो उसका column था उसको आपने rows बना दिया तो you have actually put everything in the line. So first row and first column are together which will result in mod A. बाकी दूसरा तीसरा entry 0 हो जाएगा. Then again second row का first entry 0 हो जाएगा. Second row फिर से rows और column हो चुका है mod A and then gone. So you get a diagonal matrix of mod A. So you can say that matrix is mod AI. So I hope everybody got this result. A into adjoint of A or adjoint of A into A is equal to mod AI. Everybody got this answer or not? Do I have to explain it? Explain kar do. This is coefficient matrix X. I'm going to take a transpose. So क्या बन जाएगा? So I'm going to create adjoint A. So this would be B1. This would be A1, B1, C1, A2, B2, C2, A3. Right. Now, how do you multiply A into adjoint A? So the first row will go with first column. So this and this is det. Now the first row goes with the second column 0. The first row goes with the third column 0. So only this guy is det A. Everything has become 0. Now this guy goes with first row as 0. This guy goes with the second row det. This guy goes with the third 0. This guy goes with the first guy 0. This guy goes with the second guy 0. This guy goes with the third guy det A. So you got something like 0, 0, 0, 0, 0, 0, det A, det A, det A, which will sweep out det AI. Right? Now we are going to prove a very important result. Now I know A into adjoint A is equal to adjoint A into A is equal to det AI, which means We all are one is very important in our numbers stories, and similarly I is very important for our inverse stories, arithmetic stories. So I know this is A into adjoint A. I can write this is nothing but adjoint A upon mod A is equal to I. Or you can write this way also, whatever, because it's a commutative nature, no need. And that A is nothing but a scalar number. Now I can multiply A inverse both side, so this will become 1. So adjoint A upon mod A inverse. So when you have to find the inverse of a matrix, you cannot find better way this, right? इससे भी एक अच्छा method आएगा, but this is one of the best method. So you just have to find adjoint of A, and then you just have to multiply with 1 upon det, and that gives you inverse. And if det A is 0, what does it mean? A is a singular matrix. Yeah. Now my question is, can you find me the det of adjoint of A? Det of adjoint of A. Tell me what should be the det of adjoint of A. This equation is a powerful equation. It will help me find my this is a very useful equation. A into adjoint of A is equal to mod AI. Now my idea is to find det of adjoint of A, and det of A we already know it's pretty easy to find, right? So what we are going to do, we are going to take det both side. So det A into det of adjoint A, of course we can do with the mod this property, would be equal to mod A to the mod AI pe mod. Right or wrong? Okay. So mod A into adjoint det A, ये क्या होगा? Det A या det A to the power n? Huh? You again missing the basic? Det A or det A to the power n? क्या होता है? तो ये क्यों नहीं करेगा ये काम? K क्या है? ये K ही तो स्केलर है ना, यहाँ पे I मैट्रिक्स है यहाँ पे. Understood? So what is adjoint of A? More. This is what we are talking about. Okay, adjoint of A का det is nothing but det of A to the power n minus 1. Excellent. Do you want to solve the question or should I go further, because we don't have much time? You want to solve one question on it? Okay. I wanted to discuss one important thing that people they actually don't discuss much, but that is like rank of matrix, but I think we won't be able to do that. That is why I was going fast. Det of A 3 by 3 is 3. Find adjoint adjoint of 2 into A. See, adjoint of now adjoint को देख के घबराने की जरूरत नहीं है. Adjoint is nothing but a matrix. So why don't we think adjoint 2A as matrix B? Then I can say I am considering adjoint 2A as matrix B. So what I have to find is adjoint of B, right? And adjoint of B is nothing but mod of B to the power, that is 2. Okay or not okay? Okay. Now time to come up with adjoint of 2A now what was the det of adjoint of kachra to the power n minus 1. Similarly this would result in right, and what is det of Ka? What is the answer going to be? 2 to the power 12, right or wrong? And what is det A? So 2 to the power 12 into 1 minute. ज़्यादा हो गया ना? Okay. Obviously we have to do it layer by layer. We are considering this matrix B, so this become mod det B square. Now putting back adjoint 2A again layer by layer. I'll just remove adjoint, so it will become 2A ka square. And what is 2 det A? That is 2 cube det A. That is 2 cube det A. Now 3 2 2, that is 12. 2 into 2, that is 4. Clear? Now coming to the most important application, it's called simultaneous equations. Simultaneous equations, when you have to solve 3 equations of 3 variables, you have 3 ways basically. One is rank method. Okay. Sorry, one is Cramer's law. One is inversion method, which you have to do in your board examination. You have to use either Cramer's law or inversion. And better than that, we have the best one called rank method, which will help, which is not applicable for board examination, but and you know matrix inversion and all these are like very, and Cramer's law also lots of calculations, right? If it's a homogeneous equation, then Cramer's law is a handy thing. Why? Okay, first we must understand what is simultaneous equation. What were linear equations in 2 variables? जब आप लोग class 9 में पढ़ रहे थे तो what was linear equation in two variables when you were studying class 9? It was simply 2 lines. When they meet, one solution. When they coincide, infinite solution. When they do not, when they are parallel, no solution. And we were in 2D dimensions, right? 2 dimensions. So when you have at least one solution, you call it consistent. One or infinite was the case of consistent, and when you had no solution, inconsistent. And this was the story. Now here you got 3 equations called a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z plus d2, a3x plus b3y plus c3z is equal to. These three equations represent something. What is it? You haven't done 3D, right? So how you will be able to tell that? These three equations represent planes. Plane 1, plane 2, plane. What are planes? An infinite sheet. An infinite sheet is called plane. This is one plane. This is another plane. So I can find infinite planes just with the help of this, right? This is one plane. Then you have this plane ऐसे आ रहा है, right? So this is not that handy. Okay, this is another plane. Okay, so you have so many planes. So I gave you 3 planes. Okay, I'm sure one solution का मतलब समझ में आ गया होगा. What does one solution means? They are sharing one common point. Let's say I'm talking about that corner. Okay, you have one plane, you have 2 plane, and you have 3rd plane. They all are meeting at just one point. They have only one point of solution, and that is the vertex. So when 3 planes meet at one point, we call it one solution. When you see 3 planes, these 3 remotes are 3 planes. Now these 3 planes are sharing one common line. This is the line, right? One common line. So in this case we say infinite solution. What do we say? Infinite solution. And what are parallel solutions? When all the 3 planes are either parallel or they are making something like prism. You have 2 planes meeting at apex, and the 3rd plane is the base. So when you see these type of situation, you call it no solution, because there is no common point between these 3 planes. Pairwise, yes, they have infinite solution, but we are not interested in pairwise. We are interested in 3 equations. So you understand what does it mean when I say one solution? Infinite solution, no solution, right? Infinite solution, a line of intersection. They have a common line. One solution, they have a common point. And no solution, there can be 2 cases. Either they are identical, the planes are identical, parallel planes are identical planes, and identical planes, or they are like, है ना? So यहाँ पे उस समय कोइंसिडेंट लाइन कर रहे थे, आइडेंटिकल इक्वेशंस को हम कोइंसिडेंट बता दे रहे थे, लेकिन अब हम 3 प्लेन्स को डिफरेंट कर देंगे, राइट? और इंटरफ्लाइट सॉल्यूशन का मतलब दे आर शेयरिंग अ कॉमन लाइन. जैसे एक फैन है, 3 टर्बाइंस लगे हुए हैं. So these 3 blades are sharing a common line. So you have infinite solution. So simultaneous equation को solve करने के लिए 2-3 methods हैं. First we'll be using Kramer's rule. How to handle this? देखो, ये story है. If you see, observe, आपने ऑलरेडी मैट्रिक्स इन्वर्जन ही पढ़ा होगा, तो आपने देखा होगा कि इट हैज़ क्रिएटेड आउट ऑफ मल्टीप्लाइंग कोफिशिएंट मैट्रिक्स विथ वेरिएबल मैट्रिक्स टू गेट योर कांस्टेंट मैट्रिक्स, राइट? सो आई एम गोइंग टू कॉल दिस मैट्रिक्स एज कोफिशिएंट मैट्रिक्स. तो आपने कोफिशिएंट मैट्रिक्स बना दिया just using the concept of taking away the coefficients. d1, d2, d3 has to be kept on the right. And then you try to find the det of it. So I'm going to call this as delta. What I'm going to call it? Delta. Now I'm going to redefine 3 more determinants. One is delta with small x. I will hide all the coefficient of x and I'll start writing b. I'll replace that with d1, this is how I find del x. Del y small y with a sub. It's not multiplying with that. It's simple representing which matrix you are talking about. So again, this will remain A1, A2, A3. And you have that Z. So again, A1, A2, A3 as it is, B1, B2, B3 as it is, D1. So you created 4 dates. You created?
4 dates.
It's a lengthy way. So you created 4 dates, you have found 4 dates, right? Now let's say if delta, ये जो निकाला है, इसके 2 cases बनेंगे. आपने डेल्टा निकाला. Delta is either equal to not equal to 0 or equal to 0. So when delta is not equal to 0, what is the solution? One solution, because x is, now I am going to find what is x. X, y and z. X is going to be del x upon delta, और उल्टा था. Just let me see. ठीक है. And then del y upon delta, del z upon delta, right? So this is how you are going to find your x, y, z. And I never use this method. Del x upon delta, del y upon delta, and del z upon delta. Clear? It's very lengthy. Only helpful in homogeneous cases. I'll discuss what are homogeneous cases later on. Now, if del is not 0, then I surely got unique x, y, z. And getting unique x, y, z means I got unique point. And when I get unique point, it means one solution. So no contradiction. When delta is not 0, you got a unique solution. We don't have to talk about it, right? When delta is equal to 0, then there arises 2 cases. One case arises that delta 1, delta 2 and delta 3, means delta x, delta y, delta z, they all 3 are equal to 0. If this is the case, what is the solution? Infinite. Why? Because we know, इस equation को तुम क्या लिख सकती हो? Del into x is equal to del x, and 0 into x is equal to 0, which all can satisfy that, all the values of x. Similarly, del y is equal to del y, which means 0 into y is equal to 0. It also can be satisfied by any y's. And similarly, you got del z is equal to del z, again 0, 0. So when this is the case, you have infinite solution. When all the 3 guys, del 1, del 2, del 3, all are 0, it means you have infinite solution. And when at least one of the 3, if at least one of the 3 is not 0, अगर एक भी बंदा not 0 हो गया, तो how many solution? No solution. Okay? So very straight. तो आप कह सकते हो कि अगर आपका नो सॉल्यूशन है तो कौन सा 2 केसेस हो सकता है? ईदर इट्स अ प्रिज्म और एट लीस्ट 2 ऑफ द गाइज आर पैरेलल. At least 2 of the guys are parallel, or it's making prism. है ना prism? Now coming to the second method called matrix inversion method. So you have something like A1, A2, A3, B1, B2, B3, C1, C2, C3, X, Y, Z is equal to D1, D2, D3. Do you understand what is it? It's nothing. If you multiply them, what you will get? you will get a matrix called 3 by 1, and you will get the matrix here 3 by 1, and in the matrix 3 by 1 every element would be a1x plus b1y plus c1z is equal to, second would be a2x plus b2y plus c2z, and third would be, and all the each is corresponding to d1 d2 d3, that is the equality of matrices. So we can say this is like a, that representation can be given a structure, that matrix has been given structure. So I can say matrix A into X is equal to B. Right or wrong? Two cases arises. Det of A is 0 or not 0. When det is not 0, A inverse exists. A inverse, and now you have to be careful with the commutativeness. So I am going to put A inverse here. Right? So X is going to be, and hence you will have your solution. Right? Now the problem comes here. When det is 0. So what are you going to do? You are going to take the help of Mr. Adjoint. You are going to take the help of adjoint. So what you are going to get adjoint of A into AX is equal to adjoint of A into B, and adjoint of A into A results in delta A I now you know that delta is 0 now. So you know that this is 0 into X into something. Now the whole story depends on this product. If this product, the right hand side, adjoint A into B turns out to be 0, then the solution is infinite. And when the adjoint of A into B turns out to be non-zero, it means no solution, because 0 is not equal to non-zero, is equal to non-zero is no solution story. Understood? ये flow याद रहना है, that's important, otherwise you will forget. Okay. Now, what is the rank of a matrix? What is rank of a matrix? देखो, you have a matrix, ठीक है, and then now you are going to create a sub matrix by deleting the rowth and the column. So you will get, let's say you have something called 4 into 3 matrix. Okay, so you have 4 into 3 matrix. So you have or you call 3 into 4. Okay, so you have 3 into 4, 3 rows and 4 columns. Now you are going to create sub matrices. You are going to create सब मैट्रिक्स क्रिएट करने का क्या तरीका होगा? यू हैव 4 कॉलम्स, कोई भी एक कॉलम को खत्म कर दो तो यू विल गेट अ 3 by 3 मैट्रिक्स, है ना? कोई भी एक कॉलम को खत्म करोगे तो यू विल गेट, ऐसे कितने तरीके होंगे? 4C1, 4 तरीके होंगे. सो यू विल गेट 4 सब मैट्रिसेस. उन 4 सब मैट्रिसेस में से कोई भी मैट्रिक्स का डेट अगर नॉन जीरो आ जाता है तो उसका रैंक 3 हो जाएगा. ठीक है. और अगर मान लो किस्मत ख़राब है और उन 4 मैट्रिक्स को मेहनत करके हमने निकाला और मेहनत करके डेट निकाला और फिर पता चला कि वो चारों ज़ीरो हैं, तो व्हाट वी हैव टू गो, वी आर नॉट गोइंग टू सेटल विथ 3, बट नाउ वी हैव टू डिलीट 2 columns and 1 row. And for deleting 2 rows and 1 column, you are the combination got 4C2 into 3C1, which again means a hell lot of calculation, which means almost 18 matrices. Now you have to cross check 18 matrices and then you have to find the date of all those 18 matrices. And if you are lucky, if you are able to find one of the matrices is not zero, then the rank would be 2. And if you fail there also, then you will go to 1 by 1 matrix, right? So this is how we define rank of a matrix. So of course we are not going to do this way, है ना? Otherwise why would we talk about rank then? It would be a difficult thing. So आपको बस इतना पता चल गया कि किसका रैंक होता क्या है. निकालने का तरीका हम अभी सीखेंगे, सीख नहीं पाएंगे. ठीक है, 11 पीस हो गया है. तो आई एम जस्ट गिविंग यू आइडिया. नेक्स्ट क्लास में प्रोबेबली आई विल टेल यू हाउ टू फाइंड द रैंक्स एंड ऑल. द सेकेंड थिंग, आप 2 मैट्रिक्सेस हमेशा बनाएंगे. एक मैट्रिक्स होता है, 2 नहीं, आप एक ही मैट्रिक्स बनाइए. A1, A2, A3, सॉरी A1, B1, C1, D1, A2, so you got your 3 by 4 मैट्रिक्स. और इस मैट्रिक्स को मान लीजिए आपने कहा B, ठीक है, और A मैट्रिक्स हो गया कोफिशिएंट मैट्रिक्स. जो हम मेथड सीखेंगे उसके लिए आपको इसको सेपरेट बनाने की ज़रूरत नहीं है, इसी में ही आ जाएगा. तो आप बस इतना समझिए, जब रैंक ऑफ ए इट इज डिनोटेड बाय रो एंड रैंक ऑफ बी is equal to the actual order of this, that is 3 by 3, in this case 3, then you say one solution. One solution. When you got row A is equal to row B but is equal to 2 or 1, then you say infinite solution. And when you have row A, no solution. Okay, so how we are going to do that, I don't think we'll be able to find out right, but we won't be able to do it. So just I'm closing it here. तो आपको समझ में आ रहा है? ये कंडीशन, लेकिन द मिस्ट्री स्टिल रिमेन्स हाउ टू फाइंड द रैंक. I'll just give you a hint. You understand elementary row transformations? Everyone understand elementary row transformations? See what you're going to do. This matrix is called augmented matrix. This matrix is called augmented matrix. You have this 3 rows and 4 coefficients and constants also, d1 d2 d3 जो right side में था. You have created a augmented matrix. Now this matrix is nothing but equation. This side is your equation, right hand side. So whatever transformation I do on the left, on the right, the equation doesn't change. If I multiply left hand side by 2, I can multiply the right hand side by 2, right? Similarly, you have already, I think, I am just assuming that you have already finished elementary row transformations in your NCERT text, right? So what, from here, I am going to create Euclidean form. Augmented matrix से मैं क्या बनाने वाला हूँ? Euclidean matrix. ECHLEON. सुनने में नाम खराब लग रहा है, लेकिन है नहीं. क्या करना है आपको? What you have to do, what you have to make sure that A2, A3 and B3, ये जो 3 बंदे हैं, they are lower triangular का part. You have to make them 0. You have to make them by elementary row transformation. So what is the purpose? आपको इसको 0 करने के लिए क्या करना पड़ेगा? रो 2 को रो 1 से कुछ माइनस करेंगे तो 0 हो जाएगा. इसको ही 0 करना है, सिर्फ A2 को. ये हो रहा है नहीं हो रहा है डजंट मैटर, हमें इसको 0 करना है. और A3 को भी जब इस एक साथ हम 2 ट्रांसफॉर्मेशन कर सकते हैं. A3 को भी रो 1 के साथ मैं इंटरेक्ट करा के इसको 0 बना दूंगा. तो ये 0 एक ही स्टेप में हो जाएगा. ये 0 एक ही स्टेप में हो जाएगा. ये कुछ और बन जाएगा, ये कुछ और बन जाएगा, ये कुछ. अब हमारा पर्पस है इसको 0 करना. तो इसको इसके साथ इंटरेक्ट करोगे तो ये गड़बड़ हो जाएगा. सो यू मस्ट इंटरेक्ट विद दिस और इसको 0 बना दो. द मोमेंट यू गॉट दीज 3 guys 0, नाउ यू हैव टू लुक इनटू दीज 2 guys. C3 D3 ये क्या बना? एंड देन योर आंसर विल अराइव. देखो, अगर C3 नॉन 0 है तो मतलब यू 3/3 मैट्रिक्स का जो रैंक है वो 3 है. तो रो ए क्या हो गया? 3. और ये जब नॉन 0 हो गया है, डजंट मैटर ये 0 है कि नहीं, ये 4 बनता जो इसका भी रैंक क्या हो गया? 3. सो यू से नो 1 सॉल्यूशन. कैसे निकालेंगे अभी मैं बता दूंगा. ठीक है, अंडरस्टूड. आपने उस ट्रांसफॉर्मेशन के बाद देखा कि ये दोनों 0 हो गया है. दोनों 0 हो गया मतलब योर स्टोरी हैज कम अप टू दिस पार्ट, अपर पॉइंट. और अगर ये दोनों नॉन 0 है और ये भी नॉन 0 है तो इसका, ये दोनों में से कोई नॉन 0 हो गया तो इसका मतलब 2 रैंक 2 बन चुका है. तो रैंक 2 मतलब इनफिनाइट सॉल्यूशन. तो इसमें सॉल्यूशन निकालने की जरूरत नहीं होती है, बट यू कैन फाइंड द इक्वेशन लाइन, वो हम सिखा देंगे. और अगर मान लो ये 0 हो गया है तो इसका मतलब इसका रैंक 2 हो चुका है, और ये नॉन 0 तो इसका रैंक 3 है, तो दे आर अनइक्वल, सो नो सॉल्यूशन. अब जैसे आपने यूक्लिडियन फॉर्म में लाया था तो यूक्लिडियन फॉर्म में ये 0 हो गया था, ये C3 था, और ये कुछ था, कुछ ये दोनों नॉन 0. तो इससे आपको क्या पता चला? दिस कोफिशिएंट इज मल्टीप्लाइड विथ Z टू गिव यू D3. तो यू कैन क्रिएट योर D3. Z निकल के आ गया, ये 0 बन चुका है. इट्स अ लीनियर इक्वेशन इन 2 वेरिएबल y एंड z. सो जो भी ये आया है, नॉट B2 C2 बट जो भी आया है इनटू y प्लस z इज इक्वल टू D2, वो जो भी ये आया है, एंड यू हैव ऑलरेडी क्रिएटेड योर z. उसमें पुट करो, यू विल फाइंड योर y एंड देन यू कैन फाइंड योर. इज अ easy way. It's a easy way. You just need 3 steps. One step making this 2 0, third step making this is 0. You got your matrix. When you got your matrix, you can easily check out what's the row A, what's the row B, just by looking at the, without finding their dead, just looking at non-zeros. है ना? 3/3 में अगर कोई भी 3/3 मैट्रिक्स में अगर इस रो में एक भी कॉलम आ जाता है विदाउट नॉन जीरो एंट्री, है ना, इसमें अगर नॉन जीरो एंट्री है तो मतलब रो उसका उतना ही है. ठीक है, दैट इज द होल स्टोरी. ओके.